Hello students, let's learn math subject standard 8 chapter 11. Chapter name is mensuration. First let's recall what were the formulas of rectangle, triangle, square, parallelogram and a circle. Now this is the length is B and this is the width is A. So what will be the area of this rectangle? It will be A into B. Now suppose if you take a square, the side is A, so you know square has all sides same, so it is A into A, area, that is length into width. Now if you take the case of a triangle, it is half into base is B and h is height, so half into B into h is the formula of triangle. Okay, now if you take the area of a parallelogram, what it is B into h. B is the base of the parallelogram, h is the perpendicular height. And what is the formula of a circle? The area of a circle is pi into, here radius is B, so it is pi b square. Okay, the formula of circle is pi r square. Here instead of r it is b, so it is pi b square. Now let's solve one exercise 11.1. We will see the first sum. A square and a rectangular field with measurements as given in the figure have the same perimeter. These two figures have the same perimeter, that is the sum of all sides of both these are same. Now we have to find out which field has a larger area. The perimeter is given. Okay, you know when this square has all sides same, and perimeter of a square, you know it is this side plus this side plus this side plus this side. So you will put in the formula and see what you will get. This is 60 meters the one side, so 60 into 4 will give you 240 meter, right? The perimeter is 240. Now perimeter of this is 240 and perimeter of this is also 240. So how will we get the side of this? The length is given, you have to find the width. So 240 will be equal to 2 of L plus B. You can write this as 2L plus 2B. Now 2L, you know it is 80 into 2, 180 and 180, 80 into 2. 240 will remain as it is. 8 2s are 16, so 240 minus 160, it is 80. So 2B is 80, therefore B will be 40. So we have solved this first sum. Now let's solve question number 2 of exercise 11.1. Question is, Mrs. Kaushik has a square plot with the measurement as shown in the figure. She wants to construct a house in the middle of the plot. A garden is developed around the house. Find the total cost of developing a garden around the house at the rate of rupees 55 per meter square. The size of the plot is given as 25 meter by 25 meter, that is, it is a square. And the house is constructed in the rectangle 20 meter by 15 meter. Rest space is left for garden. So we have to find out the total cost of developing garden. The rate of the developing garden is given for per square meter, it is rupees 55. So what we will have to do, we will have to deduct the area from the square we have to deduct the area of the rectangle, then we'll get the area of the garden. Area of square we know it is length into breadth, that is 25 into 25, and we have to minus the rectangle area, that is 20 meter into 15 meters. So on solving we will get this step. After solving we will get the answer as 325 meter square, and we have to multiply that with the rate, that is 55 rupees per meter square. So you will get the total amount that is required for developing the garden. In this way you can solve rest all the five problems. Let's see the fifth one. An ant is on the floor. For which food piece would the ant have to take a longer round? Remember, circumference of the circle can be obtained by the expression C is equal to 2 pi r. The circumference of the circle is given by the formula 2 into pi into r. R is the radius of the circle. Now there are three figures A, B, C, D in the given figures as shown. Let A be the point in each figure from where the ant starts moving on the food pieces. She is to reach the initial point after moving around the boundary of each food piece. So if the ant starts from, if we take the example of this first A1, the ant will start moving from point A, it will travel to B, and then it will come again at A. So we have to find the total distance moved by the ant. Now for this shape A, the formula is given by half of 2 pi r, where 2 pi r is the circumference of the circle, and we are taking half because since it is a semicircle, and we will add BA distance, that is the diameter. If you look at figure B, it is the shape of a semicircle, that is half of the radius, half of the area of a circle, or half of the perimeter of the circle. Here we have to find out the perimeter of this arc. So it is half of 2 pi r. 2 pi r is the perimeter of a circle. Since it is half, since it is a just an arc, so we are taking half of it, that is half of 2 pi r plus this distance 1.5 and this distance 2.8 centimeters. 1.5 will be 2 times, this distance is 2 times, and 2.8 is 1 time, and plus this distance. So all, if we add, the ant will move from point A, it will travel to B, it will move to C, D, and then come back to A. So the total distance will be the perimeter of that object. So it is half of 2 pi r plus BC plus CD plus DA. So when we add all this, we get the answer as 5.8, sorry, 10.2 centimeters. Similarly, we'll do that for C shape of the food. Same way we have to find the perimeter of that arc, and we have to add the triangular portion. So when we compare all the distances. For A it is taking 7.2 centimeters, for distance B 10.2 centimeters, and uh, for shape C it is taking 8.4 centimeters. So 10.2 centimeter is the greatest distance. So the ant will have to take a longer route for food of shape B. Now let's see how to find the area of a trapezium. This is the shape of a trapezium. You can clearly see when you connect point E to C, it is divided, this trapezium it is divided into a rectangle and a triangle. So if you find the area of this rectangle and add the area of triangle to it, you will get the area of the trapezium. Here we will substitute the formulas of the triangle: half of base into height plus area of the rectangle, and when we solve it we will come to a formula which says that half of a plus b, the sum of the parallel sides into h. H is the perpendicular distance. So this becomes the formula for finding the area of trapezium. This also you have to remember along with the other formulas, that is area of rectangle, area of triangle, area of circle, etc. Now let's see how to find the area of a general quadrilateral. This is a quadrilateral. You can find it by drawing a diagonal connecting points A and C, that becomes a diagonal, and then we will draw perpendicular from B which will meet AC, and will drop a perpendicular from D meeting AC. So this will become the perpendicular height of this triangle. You can write the formula of area of this triangle ABC plus area of triangle ADC. When you add these two areas, you will get the area of a quadrilateral. Here are some shapes of a polygon. If you want to find the area of this, it is very difficult. So we can reduce this polygon into triangles. We can divide it. So if we draw a line connecting point A and point C, and if we drop a perpendicular from B, you will get this triangle ABC. If we draw a line A connecting point A and D, and dropping a perpendicular from C, will get triangle ADC, and we'll get a triangle ADE. So we have to divide this into triangles, rectangles, and add sum of them will be the area of the polygon. Now you take this example. This is the shape of a polygon. There are two methods of finding. One, by joining this point N with point Q and divide it into two trapeziums. Second method is drawing line joining points M and point O and divide it into two triangles and one rectangle. By any method if you use, you will get the same answer. So you can use whichever method is convenient for you and get the answer. Now let's solve exercise 11.2. We'll solve the first sum. It says that shape of the top surface of a table is a trapezium. Find its area if its parallel sides are 1 meter and 1.2 meters. These are two parallel lines. The size of that is 1 meter and 1.2 meter. And the perpendicular distance, that is area of that trapezium. Now we know the sum of the area of the trapezium. You can find by two methods. One is you can divide this trapezium into two triangles. These are two triangles and one rectangle. Or you can directly use the formula. It says that half of sum of parallel sides into perpendicular distance between them. These are the sum of parallel sides and this is the perpendicular distance between them. So when you put that in the formula, you will get the area of the trapezium. Similar way, you can solve other examples. Now let's see How to solve sum number 4? It says that the diagonal of a quadrilateral shape field is 24 meter. This diagonal they have given as 24 meter, and we have to find out the area. So clearly it is divided into triangles. We have to add the area of all the triangles. Triangle number 1, triangle number 2, triangle number 3, triangle number 4. That will be the area of the quadrilateral. Now let's solve question 6 of exercise 11.2. Find the area of a rhombus whose side is 6 cm and whose altitude is 4 cm. If one of its diagonals is 8 cm long, find the length of the other diagonal. Rhombus is given which has side 6 cm. Here the altitude is given as 4 cm. So now if this rhombus is divided into two triangles, and when we add the two triangles, we'll get the area of the rhombus. So we will join point B and point D, and we will divide that rhombus into ABD triangle and DBC, which both are equal. So if we calculate area of one triangle and double it, it will become the area of rhombus. Another formula for finding rhombus area is you have to multiply the diagonals, and along with the result you have to multiply half. That is area of rhombus equal to AC, this diagonal, and area of diagonal BD. So this is the formula of the rhombus, which you have to remember. This one, half into AC into BD. Similar fashion, you can solve other problems as well. Let's see this pentagonal shaped park. We can divide this pentagonal shaped park, divide it into triangle and a rectangle, and we'll add both of them. We'll get the area of the trapezium, pentagonal shaped park. Now let's learn about solid shapes. This is a cuboid. You know, any shoe box or any box for packing which is rectangle in shape, it is called a cuboid. This cylinder, you know, any water bottle, it has the shape of a cylinder. Then comes a cone, ice cream cone, you know, or any funnel. It looks like a cone. This is a cube. Cube is made of a square. Pyramid, it is made of a triangle or on all sides, and the base is a square. Now let's see how many. First let us see what is an edge, what is a face, and what is a vertex. Now this line, you can see the perimeter of this rectangle is called the edge. These lines are called edges, and where two edges meet, it is called a vertex. And this side, whole side, is called a face. This is also one face. This is also one face. Now, similarly, cylinder has a curved surface area. Cuboid has a flat surface area. Cuboid has how many faces? 6 faces. These two faces will be identical. The top and bottom will be identical. The front and the back will be identical. Now, if you take the case of a cylinder, this will be equal to this. Okay, the circular base will both be equal at the top and bottom. Now let's see how to find the surface area of a cuboid. Suppose this is a box. I told you a shoe box or any toothpaste box. You just open it. If you open it, it will be of this shape. And they are made of rectangles. Rectangle number 1, rectangle number 2, 3, 4, 5, 6. 6 rectangles. If you add the area of all these 6 rectangles, what will you get? You will get the formula as 2 times length. This is length. Length into breadth plus 2 times B into H, these two, plus 2 times H into L, these two. So this is the formula of a cuboid which you have to remember. It will help you for solving sums. This is the formula to find surface area of a cuboid. 2 into LB plus BH plus HL. Now, what is lateral surface area? Lateral surface is the face excluding the top and the bottom. That is, the area of all the sides is called the lateral surface area. Now, if you take this cuboid, the lateral surface area will be this side plus this side, the back side of this and the back side of this, excluding the top and bottom. That will be the lateral surface of the cuboid, and it is given by formula 2 times H into bracket L plus B. Okay. This formula you have to remember. Now let's see the surface area of a cylinder. This is a cylinder and we cut it this way and we open it. It will open into a rectangular sheet. Separate the top and bottom. They will appear as a circles, 2 circles. Now you know the area of a circle is pi r square and area of a rectangle is 2 pi r into h. Why 2 pi r? It is a circle and we have opened that. So from here, if you measure, this length is 2 pi r into h is the total surface area of this rectangle. Right? The length multiplied by the height is the area of a rectangle. In this case, the length is curved, so it is 2 pi r. When you add these two, formula becomes 2 pi RH is the lateral surface, that is the curved surface. This one is 2 pi RH. And what is the total surface? Total surface will include the top circular portion and bottom circular portion. So you will have to add 2 pi r square to 2 pi RH. And this can be rearranged and written as 2 pi r r plus h, or you can say h plus r. So this formula also you have to remember. Now let's solve exercise 11.3. We'll solve the second question. It says that a suitcase of measure 80 centimeter by 48 centimeter by 24 centimeter. It has three dimensions. One is length, width, and other is height. This has to be covered with a tarpaulin cloth. How many meters of tarpaulin cloth of width 96 centimeter is required to cover 100 such suitcases? First, you have to understand the question. Now, to cover this suitcase, that tarpaulin will have to be wrapped all around. So, total surface area is considered. Now, what is the formula to find the total surface of a cuboid? It is 2 times L into B plus 2 times B into H and 2 times H into L. This is the formula. We have substituted the values and we got the area as 13824 centimeters square. Now we have to find out how many meters of cloth of width. Specifically, they have given 96 centimeter width is to be used to cover such 100 such suitcases. So area of 1 meter of tarpaulin will be equal to 100 times 96 centimeter square. That is the area of 1 meter tarpaulin. You understood? You have to cover 100 suitcases. So 100 numbers into this width given is as 96 centimeters. They have specifically said that you have to use 96 centimeter width of the tarpaulin. So the area of 100 suitcases will be 13824 centimeter square. Now to find out tarpaulin covered, what we'll do? 100 into 13824 divided by 9600. Area of one tarpaulin we have to divide. So we'll get 144 meters is the length of the tarpaulin and it will be of width 96 centimeters. I hope this is very easy. Now let's see how to solve question number 4. This is a cabinet. Dimensions are given of the cabinet and we have to paint the outside of the cabinet. That means we have to find the total surface area. So using the formula, we will find the total surface area. And similar way you can solve all other problems. Let's see problem number 7. It says that a closed cylindrical tank of radius 7 meter and height 3 meter is made from a sheet of metal. How much sheet of metal is required? You know R is given as 7, height is given as 3. Total surface area of cylinder is what? 2 pi R. You remember that formula which I told you to remember? Area of two circles plus area of the portion of the cylinder. That is 2 pi R H plus R is the formula. You can directly use this formula. Here they have considered individual areas of circles and that rectangle. You can directly use that formula, which it was 2 pi r into bracket h plus r. Now let's see how to solve question number 9. It says that a road roller takes 750 complete revolutions to move area of the road if the diameter of the road roller is 84 centimeter and length is 1 meter. That means they have given a, the road roller is made of a cylindrical wheels. Okay. What all information is given? Length is given as 1 meter, diameter is given as 84 centimeter. So radius will be half of diameter, that is 0.42 meters. You have to convert that into meters. Now you know the surface area, curved surface area of the roller, it is 2 pi RH. All dimensions have to be same. So you can convert all dimensions to meters. If not, now the area is found out, it is 2.64 meter square. And area leveled by the road roller in 750 revolutions, that means 750 multiplied by that area curved surface will give you the area of the road leveled. Now let's learn about volume of cuboid. What is the volume of a cuboid? That is length into breadth into height. That means how much total volume it can contain. Suppose this is a box. What is the volume? That means how much quantity of liquid if you pour in that box, how much liquid can occupy. That is the volume. Volume of a cube is also same, length into width into height. Now let's see the volume of a cylinder. Volume of a cylinder is the area of this base into the height. Area of base is what? Pi r square, that is the circular area, into height, that is the volume. How much volume you can pour. So that will be equal to pi r square h. This is the formula of a cylinder. Formula of a cuboid or a cube is L into B into H. These two formulas also you have to remember. Volume is nothing but the capacity. Now let's see a solved example. Rectangular piece of paper 11 cm by 4 cm is folded without overlapping to make a cylinder of height 4 cm. Area of this paper is given and the height of the cylinder is given. You have to find the volume of the cylinder. Now perimeter of the base is 2 pi r. 2 pi r is what? Is given as 11. It is rectangular piece of paper, that is 11 is how much? 2 pi r. Okay, this one. This is 11, this is 4. We have cut this paper and we will fold it to make a cylinder of height 4 centimeter. You have to write the units. Now radius is given as 7 by 4. When we solve this, we get the radius as 7 by 4. The volume of cylinder formula is what? Pi r square h. Pi value we know 22 by 7, it is a constant. R radius is what? 7 by 4. We have got the value from here. The height is 4 centimeter. So when you solve, you get The answer is 38.5 centimeter cube. Now let's solve exercise 11.4. We'll solve the first sum. It says that given a cylindrical tank, in which situation you will find surface area and in which situation you will find volume. To find how much it can hold and number of cement bags required to plaster it, and third, to find the number of smaller tanks that can be filled with water from it. To find how much it can hold, that is the volume. Second, cement bags required to plaster it, that means the surface area. And to find number of smaller tanks that can be filled, that is the volume. So you have to find first volume, surface area, and then volume. Now let's solve question number 2. It says the diameter of a cylinder is 7 centimeter and the height is 14 centimeter. Diameter of cylinder B is 14 centimeter and the height is 7 centimeters. Now, without doing calculations, can you suggest whose volume is greater? Verify it by finding the volume of both cylinders. Check whether the cylinder with greater volume also has a greater surface area. Now diameter is given, height is given, okay, of both cylinders. Now directly we can put that values in the formula of the cylinder. The surface area of cylinder is, here it is written separate, 2 pi RH plus 2 pi R square. You can directly use the formula which we had studied. The total surface area will be 2 pi R H plus R. This formula also you can use, and on substituting you will get the surface area of cylinder A as 385 centimeter square and surface area of cylinder B as 616 centimeter square. Now we'll find the volume of cylinder A and cylinder B. Volume of cylinder, the formula of volume of cylinder was pi R square H. Volume of cylinder is pi into R square into H. So on substituting that, we will get the volume of cylinder A as 539 centimeter cube and volume of cylinder B as 1078 centimeter cube. So just you have to replace the formulas. You have to replace the values in the formulas, and thus we can compare which cylinder has a greater volume and which cylinder has a greater surface area. Now let's see how to solve question number 3. Find the height of a cuboid whose base area is 180 centimeter square and volume is 900 centimeter cube. Now volume of the cube is given. Volume of cube is what? Area of base into height. Okay, now the area of base is given as 180 centimeter square. You have to find out the height. So we'll rearrange the formula and work it out to get the height of the cuboid. Now let's see how to solve question number 6. The milk tank is in the form of a meter and length is 7 meters. From the quantity of milk in liters that can be stored in the tank, now you have to find the volume of the tank. So volume of tank is what? Pi R square H. All values you have to put. Radius is given 1.5, H is given as 7 meters. You have to put these values in the formula and get the volume of the tank. Now let's see question number 8, the last one of this chapter. Water is pouring into a cuboidal reservoir at the rate of 60 liters per minute. If the volume of reservoir is 108 meter cube, find the number of hours it will take to fill the reservoir. So, volume of reservoir is given 108 meter cube. Now you know that 1 liter, 1 meter cube has capacity to hold 1000 liters. So 108 into 1000 is 1,08,000 liters. Now since water is pouring at the rate of 60 liters per minute, time taken to fill the reservoir will be the total volume divided by the total time. Yeah. So when you divide 1,08,000 divided by 60 into 60, why 60 into 60? It is conversion of into minutes. See, here it is given clearly that water is pouring at the rate of 60 liters per minute. That means in 1 minute 60 liters of water can be filled in the tank. And now when we divide, we'll get the answer as 30 hours. So it will take 30 hours to pour 1,08,000 liters of water. With this, we have completed the chapter number 11. The sums which are required to be done as homework, you have to do it and send it to the school. Thank you.